Hello students, welcome to Examora, your smart way to prepare for the exams. Hello everyone and welcome back to part 2 of our number play series. Today we are exploring the fascinating world of advanced numerical patterns and sequences. We will dive into the mystery of palindromic sequences, look at the magical Prakash constant and see how number sequences come alive through geometrical figures. So, let's move to our session. Question. Write 5 three-digit numbers whose digit sum is 9. So, here you can pick any three-digit number that added up to 9. For example, you can take 8 plus 1 plus 0. That is 8 plus 1 plus 0, that is 9. So the number 810. Okay, so like that, we can take another number, that is 720. 7 plus 2 plus 0, that is 9. Okay, so next, we can take 612. 540. Also, 621. These all numbers, the digit sum added, we get the result 9. So the numbers are 810, 720, 612, 540, 621. Okay. So no need to write the same number. You can find a different number. Use the counting all digit which sum up to 9. Clear? Next question. What is the smallest three-digit number whose digit sum is 9? So here, to make a number as small as possible, we want the smallest starting digit. So we can't start with 0. So we can start with 1. Okay? Then we put 0 in the tens place. Clear? To hit our target 9, the last digit must be 8 because 1 plus 0 plus 8 is 9. So our answer is 108. Clear? Next question. What is the largest 5-digit number whose digit sum is 9? So to make it huge, we want the biggest digit at very front. So the biggest digit is 9, right? So we need largest 5-digit number. So what we have to do? So after that, put zeros in the next places. So they're asking 5-digit number. So we can put how many zeros? 4 zeros to next digits. So the answer is 90,000. Next question. What is the smallest 2-digit number whose digit sum is 9? So this question you have to do by yourself, okay? This is your homework question from this part. Okay? You can post your answers in comments. If there is any doubt, please free to ask. So next question. How big a number can you form having digit sum of 14? Can you make an even bigger number? So for this question, we can start with the 2 number to make a sum of 14 first. So we can take 5 and 9. Because 5 plus 9, that is 14, right? So it is putting together, we get the number 59. Okay? So next, what happens if we add 0 to this number? So 0 have a value of nothing. So they don't change our sum, right? So 5 plus 9 plus 0. The answer's still 14. But we get bigger number than 59, right? So, what if we put 0 and end 59 becomes 590. Add another 0, it becomes 5900. Yes? So add 100 zeros and number becomes bigger, but the sum stays the same. The digit sum stays 14, right? So here we can say, yes, can you make an even bigger number? The answer is here, yes, we can make. By adding zeros, we can make the number more bigger without changing the digit sum, because all these sums are the digit sums 14. Clear? Next question. Calculate the digit sum of 4-digit numbers whose digits are consecutive. For example, 1, 2, 3, 4. Do you see a pattern? So, in this question, remember, consecutive just means numbers that follow each other in order without any gaps, like counting number steps, right? 1, 2, 3, 4, etc. So here digit sums simply means adding those numbers together. Clear? Digit sum here they are using the word digit sum means adding those numbers together. So consecutive number, we have to add the consecutive numbers together. Do you see a pattern? They're asking that. So what we have to do? First we can add 1 plus 2 plus 3 plus 4. First 4 consecutive numbers, the digit sum here is 10. Okay? So next digit starting from 2. 2 plus 3 plus 4 plus 5. So here the answer 14. So next digit 3. Start from 3. 3 plus 4 consecutive numbers we have to write. So till 6. The answer 18. Next 4 plus 5 plus 6 plus 7. The answer is 22. So result we got 10, 14, 18 and 22. Right? So here, see which pattern you observe here. 10, 14, 18 and 22. Here the sum increases by 4 each time. Right? The sum increases by 4. So we are observing the pattern. The sum increases by 4 each time because all digits are increased by 1. Okay? Clear? So here we can write the sum increases by 4 each time because all 4 digits increase by 1. Okay? Next question. Write the smallest and greatest 4-digit number whose digit sum is 15. So first we have to find the smallest 4-digit number. Okay? So here, to find the smallest 4-digit number, you must make the leftmost digit as small as possible and the rightmost digit as large as possible. So here, we can write in thousand place, we can choose 1. So because it is the smallest non-zero digit, the remaining sum we needed is then 14, right? So, next we can choose 0 to the 100 place. Because it is the smallest possible digit, the remaining sum we needed again is 14. Next we can choose 1 space. Here, choose the maximum possible value to very end. So the maximum possible value we can choose is 9. So this is the 1's place. So, the remaining sum we needed by adding all these is 9 plus 1, it's 10. So remaining sum we needed to make the number 15 is 5. So we can put 5 in the tens place. Smallest possible 4-digit number whose digit sum is 15 is 1559. Clear? So I will repeat one more time. For finding the smallest 4-digit number, you must make the leftmost digit as small as possible and the rightmost digit as large as possible. In thousand place, we choose 1 because it is the smallest non-zero digit number. After that, in hundred place, we put 0. It is the smallest possible digit. After that, the remaining sum we needed is 14. So, next we can write in the ones place the maximum possible value. The maximum possible value is 9. After that, the remaining sum we needed is 5. So, put 5 in the tens place. We get the number smallest 4-digit number. Clear? So next we need to find out the greatest 4-digit number. So we make the leftmost digit as large as possible. So put 9 in the thousand place. Okay, now the sum left is 15 minus 9. 15 minus 9 is 6. Put 6 in the hundred place. This is a hundred place, we can put 6 here. The remaining sum is 0. So we can put 0 in the tens place and again 0 in the ones place. So sum all these digits, 9 plus 6 plus 0 plus 0, we get 15. Okay? So we can write the smallest 4-digit number is 1059 and the greatest number is 9600. Clear? Question number 6. Among all the numbers 100 to 1000, how many times does the digit 5 appears? So in this question, we will count how many times 5 appears in each base. That is, we have to check 100 place, tens place and ones place. So first we can check the 100 place. So we can write here, in hundreds place, the 100 digit is 5 only in the numbers 500 to 599. Okay, so in these numbers there are 100 numbers. So 5 appears 100 times. From 500 to 599, 5 appears 100 times. Clear? Okay. Next we can move to the tens place. So here, in every block of 100 numbers, that is 100 to 199, 200 to 299, etc. and 900 to 999. The tens digit is 5 in tens numbers. So there are 9 such blocks. So we can write 9 into 10. So 9 into 10, it's 90. So 90 times the 5 appears. Clear? So next move to the ones place. Similarly, in every block of 100 numbers, the ones digit is 5 in 10 numbers. So again, there are 9 blocks are there. From 10, 20, 30, 40, 50, 60, 70, 80, 90. So 10 blocks are there. So we can write 9 into 10. So 90. Here also 90 times. So we get 1 space 90 times, 10 space 90 times, and 100 space 100 times. After that, we can add all these sums. 100 plus 90 plus 90. So we get the answer 280. So we can write here the digit appears 280 times. Here the answer is 280. Okay. 280 times. Clear? So, practice all these steps one by one. We can find out these numbers very easily. It is very easy. Just you need to practice it. So, next, 7 to 1. Emma, all the numbers from 100 to 1000. How many times does the digit 8 appears? So, for this question, we can again make it 3 place values, 100 place, 10 space, and 1 space. So we can write here the hundreds digits is 8 in the numbers 800 to 899. It is 100 such numbers. So 8 appears 100 times in 100 place. Here 100 times. Okay. So next is 10's place. In each group of 100 numbers, such as 100 to 199, 200 to 299, etc., and 900 to 999. So there are 9 groups and 10 digit in 8 is 10 numbers. So we have 9 into 10 again. That is answer is 90 times. So 8 appears in 10 space 90 times. Clear? Here. Next move to 1 space. In each group of 100 numbers, the 1's digit is 8 in 10 numbers. So again, we can use 9 into 10, that is 90 times. Okay, so let's add them together. In 100 place, it's there 100 space 100 times, 10 space 90 times, and 1 space 90 times. Okay, add together 100 plus 90 plus 90. We get answer 280 times. Okay, 280 times. So we can say the digit 8 appears 280 times. Here also we can write 280. 280 times. Clear? Next, question number 8 and question number 9 is your practice question. You can write as homework. Let's move to the next session. Write all the palindromic number using the digit 2, 3, 4. So, first, let us understand what is a palindromic number is. A palindromic number is a number that reads the same from left to right and from right to left. Clear? For examples, 121, 454, 1331, all these are examples of palindromic numbers. So, since we are using the digit 2, 3, 4, and the question asks for all palindromic numbers, we make 3-digit palindromes. So, to make a palindromic number, the first and last digit must be the same. So, the possible numbers we can write here are 222, 232, 242, 323, 333, 343, 424, 434, 444. So all these numbers we can write here as palindromic numbers. Clear? So next question, write the smallest 4-digit palindromic number. So, a 4-digit palindrome has the form of the alphabet A, B, B, A. This is the form of a 4-digit palindromic alphabet. So, like this, we have to form a 4-digit palindromic numbers. Here, we can write the smallest 4-digit numbers start with 1. Clear? So, the first and last digit are 1. To make it as small as possible, the middle digit should both be zeros. So, 1001 is the smallest 4-digit palindromic number. Clear? Question number 3. Write all the palindromic numbers between 1 to 100. So here, every 1-digit number is automatically a palindrome because it reads the same forward and backward. For 2-digit numbers, both digits must be the same. So we can write the 1-digit palindromes, that is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because if you read forward and backward, the number is always same. So next we can write 2-digit palindromes. 2-digit palindromes are 11, 22, 33, 44, 55, 66, 77, 88, and 99. 100 is not a palindromic number. Clear? So you have to remember this. A palindromic number is always look exactly the same when read from left to right and from right to left. If the number changes when reversed, it is not a palindromic number. Clear? Question number 4. Write all the palindromic numbers between the numbers 100 to 1000 having 1 at unit place. So, for a 3-digit palindrome has the form of A, B, N, because the last term is repeating. Now, here the middle digit can be any digit from 0 to 9. So here, the palindromic numbers start with 101. See, the first digit and the last digit is same. Then the next palindromic number 111. Then 121. Then 131, 141, 151, 161, 171, 181, 191. Clear? So remember, the palindrome, the first and last digit must be always the same. Since the unit digit is 1, the 100th digit must be 1. So remember that in a palindrome, the first and the last digit must always be the same. Since the unit digit is 1, the 100th digit must be also 1. The middle digit can be any digit from 0 to 9. So we simply write 101, 111, 121, etc. all the way up to 191. There are 10 such palindromic numbers. I hope you clear all these things. Next question, write a palindromic number whose digit sum is 10. So, you can write any palindromic number whose digit sum is 10. Here the possible answers are 181. 1 plus 8 plus 1 is 10, answer 10. Also, I'm writing here 262, 343, 505. Any number you can write, but the digit sum is 10. Okay? Next question, how many rounds does the number 3576 take to reach Prakash constant? Let us first understand what Prakash constant is. Prakash constant is a special 4-digit number, 6174. It was discovered by the famous mathematician Dattatreya Damachandra Prakash. There is an interesting rule behind this number. Take any 4-digit number provided that not all its digits are the same. Arrange its digits in descending order to form the greatest number possible. Arrange the same digit in ascending order to form the smallest number possible. Subtract smaller number from the greater number. Repeat the same process with answer you get. No matter which valid 4-digit number you start with, you will eventually reach 6174. Once you reach that number, the process repeats forever. So for our number 3576, start with this number. First, arrange the digit the greatest number. We can make the greatest number. So 7653 is the greatest number and the smallest number is 3567. So subtract both numbers, we get 4086. Step number 2. Now take 4086, the greatest number, from this number 8640, and the smallest number we can get 468. So again subtract 8640 minus 468, we get 8172. We can move to the step number 3 because we didn't reach the Prakash constant number. Now take 8172, here make it greatest number and again smallest number, so the number then subtract. So we get 7443. Again we didn't reach. Soon move to the next step. Now take 7443, make it as a greatest number, then smallest number, then again subtract, we got a number 3996. We didn't reach yet. So again move to the step number 5. Now take 3996, then make it as a greatest number, then make it as a smallest number. Now we got the answer 6264. Again move to the 6th step. Now take 6264 and make it as a greatest number, then smallest number, subtract it. We get the answer 4172. It's not Prakash constant. Again move to the step number 7. Make it as a greatest number, 7641, and the smallest number 1467. Subtract it. Now we got that number 6174. That is Prakash constant. So for the number 3576 reaches Prakash constant in 7 rounds. Clear? This is the way we can find out the Prakash constant. Clear? Next question. By using the digit 1256, find 2 4-digit numbers whose sum is greater than 5250. So here we can write 6521 plus 6215. We get the answer 12,736. So which is greater than 5250. Clear? Next question. Write 2 5-digit numbers whose difference is greater than 5035. This question, we can do it by yourself as homework. Next question. The time now is 11:11. After how many minutes will the clock show the next palindromic time? A palindromic time reads the same forwards and backwards. For example, the time shown here 1:10, 2:20, 3:30, 10:1, 11:11. So here the current time is 11:11. Since this is a 12-hour clock, the next palatory time after 11:11 is 12:21. Clear? Also, we can find how many minutes will the clock show the next palindromic time. So from 11:11 to 12:21, how many minutes it take? So first we can write here from 11:11 to 12:11. 60 minutes are there. 60 minutes. Clear? And from 12:11 to 12:21, that is 10 minutes. Okay? 10 minutes. So 60 plus 10, that is 70 minutes. So the answer is 70 minutes. Next question. Find 3 palindromic times in a 12-hour clock whose timing is like 2:20. This one you can do as yourself. Okay? Next question. State whether the following statements are true, only sometimes true, or never true. So, the first question, 5-digit number plus 5-digit number gives a 5-digit number. So, we can write 10,000 here as 5-digit number plus again a 5-digit number, we can write again 10,000. That the answer is 20,000, right? So 20,000 is a 5-digit number. So again, this first one is correct. It gives a 5-digit number. Again, we can check with another 5-digit number, 90,000 plus 20,000. 90,000 plus 20,000. The answer we got. This is a 6-digit number. So we can say sometimes true. For this question, the answer only sometimes true. Clear? So next one. 4-digit number plus 1-digit number gives a 4-digit number. So we can write a 4-digit number, 1,000 plus 1-digit number, that is 5. The answer we get 1,005. This is a 4-digit number. So again we can write another 4-digit number, 9,999 plus 1. We get the answer 10,000. This is a 5-digit number. So this also we can say only sometimes true. Only sometimes true. Next question, 5-digit number minus 5-digit number gives a 6-digit number. So we can write the number 99,999. It's a 5-digit number minus smallest 5-digit number we can write 10,000 here. The answer is 89,999. This is a 5-digit number, not a 6-digit number. So the answer we can say this is never true. Here we can say never true. Clear? So let's move to the next set of questions. Here are some numbers arranged in some patterns. Find out the sum of numbers in each of the below figures. As you can see on the screen, we have a large group of numbers arranged inside different geometric shapes and patterns. Our goal is to find the total sum of all the numbers in each figure. Now, there are so many different methods we can use to solve this type of problem. For example, we could try adding every single number one by one, but that would take a lot of time and it is easy to make a mistake. Instead, I'm going to explain a simple technique here today. This is very easy and time-saving method that will let you find the total answer in just a few quick steps by grouping our numbers together. Let's look at the figure number 1. So in this figure, we can see 10, 20, 30. 3 number sets are there. So we can count the first number 10. So just you can count how many times the 10 appears. 1, 2, 3, 4. From here 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. The number 10 appears 22 times. Okay? So similarly, next number 20, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. The number 20 also 22 times. 10, 22 times. 20 also 22 times. Now count 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 30 also 22 times. 3 numbers are 22 times. So we can try it like this. 10 into 22, that is 220. 20 into 22, that is 440. 30 into 22, that is 660. So just add all this number, we get the answer 1320. This is very easy to find all these things. So many tricks are there. This is one of the simplest trick. Just to count, first find of the numbers, how many numbers are there. After that, you just count out how many times the number appears. So after that, sum up all the totals and you will get the result. Clear? So, next 3 questions, practice questions. After that, if you have any doubt, just comment me in the comment box. If you need free notes and this worksheet answers, just comment or mail me. I will provide you free worksheet study materials, notes and answers in a PDF format. That's all for today. We can see in the next video. Till then, stay tuned. Bye.